Hello, welcome to the second R help video for STA 371G. This video covers the R needed for homework 2. The content is as follows: histograms, QQ norm, AB line, P norm and Q norm, and also variance and standard deviation. The first thing we'll go over are histograms. To create a histogram, write hist, your data name, and then the quantitative data with which you're trying to make a histogram. To import your data, go to File, Import Dataset, from Excel if the dataset is from Excel, which they are on the second homework, and then select the data, name the data, and import. So once we have this, we can run, and our histogram is below. Next, for the normal quantile plot and AB line, do QQ norm again with your data name and the column, and it will appear on the bottom right where figures always appear. To create the AB line, do AB line, mean, data name, $, column again, and then comma, SD, data sign, column. Run these and you get your AB line. Next, we'll talk about p-norm. We use p-norm to find probabilities. Let's cover an example to try to clarify. Let's say we have a normal distribution, the mean is 5.6, and the standard deviation is 1.3. What percentage of values are lower than 4.5? To do this, put in p-norm, the value, the mean, and then the standard deviation. Run it, and this means about 19.87% of values are lower than 4.5. Remember, p-norm finds the area to the left, which is suitable in this instance because we're finding the values lower than 4.5. What if we wanted to find the values greater than 4.5? Then we would rerun the same command, except we would use 1 minus. The total area of the normal distribution is 1, so 1 minus the area to the left is the area to the right, which would be 80.13% in this case. What if we wanted to find it between 4 and 7? We would do p-norm with the same mean and standard deviation. The first number would be the values between which we're trying to find the area. We can run this and see about 75% of the values are between 4 and 7. Next, we use Q-norm. Q-norm is similar, but we find values instead of probabilities. You put the mean and the standard deviation in the same place, but you'll change the first value to whatever percentile you're trying to find. Let's say we want to find the cutoff for the 40th percentile. It would be 5.27. The cutoff for the top 10% would be the 90th percentile. I included this because you should always pay attention to the wording and be aware of the fact that you won't just type in whatever number it says. The 90th percentile would be about 7.27. Next, to find variance and standard deviation, there are two main methods I want to cover to find the variance and standard deviation. Let's say we have a scenario where we have a probability of a good year as 60%, probability of a bad year 40%, and let's say we have a piece of equipment that costs $13,000 but returns $50,000 in a good year and $15,000 in a bad year. Our total return would be our return minus the cost of the equipment. The expected value as such would be the probability of a good year times the good return, plus the probability of a bad year times the return in a bad year. The expected value would thus be $23,000. Next, if we use the formula for variance, that's return minus expected return squared times the probability. It's the sum of all the probabilities weighted by the return deviations squared. In this case, we only have two situations, one good year and one bad year, so it would be the good return minus the expected value squared times the probability of a good year, plus the return in a bad year minus the expected value squared times the probability of a bad year. Standard deviation is the square root of variance, so using square root variance would get the standard deviation. However, an easier way to do this is to do it all in one step, putting square root instead of finding variance, and you can get the same standard deviation as above. The other method that we used in homework 1 is to use vectors. It's probably more simple to use. You put in your values, the probabilities of it being both values, and then do the same computation you did in the first homework, and you get the value. So choose whatever method you like and stick with that. Thanks for watching.